In its most basic form, a function is just a rule that assigns elements from one set, a set of numbers or a set of people or a set of whatever, to another set. This first set is called the domain. The second set is called a range. So let me give you an example of a function. So everybody in here is a student of the class, so we will say that the domain are students in my fourth period class. Okay? And then the range is the city that each one of you lives in. So Reagan, I know, lives in Castledale, right? So Reagan lives in Castledale, and all a function does is assigns part of the domain to part of the range. So if I were to write every name of a student in the domain, I could draw a line to the city they live in. Now, Casey also lives in Castledale, right? So Casey also lives in Castledale. Anybody else? Briley, do you live in Castledale? Okay. So Briley lives in Castledale. Hey, Cheyenne, where do you live? So Cheyenne, are you actually in Cleveland? Okay. Yes or no? So you don't live in either. Okay, well, we'll get to you. You're a little bit of a different case. So Cheyenne lives close to Cleveland and close to Elmo, but not actually inside either of those cities. Right? So we're going to leave her blank for a second. Whitney, where do you live? So Whitney lives in Huntington. Anybody else live in Huntington? Lots of you. So Dominique lives in Huntington. Okay? And we could continue to do this for everybody in the class. Okay? Now, in order to be a function, you have a set of domains, you have a set of ranges, and you start drawing arrows. The only rule for a function is nobody in the first set, in the domain, is linked to two things in the range. Okay? So, if I were to put Reagan again, and I were to link her to Huntington, that's a problem. Can Reagan live in Huntington and in Castledale at the same time? How? Right, but so like Monday, Wednesday, and Friday she lives in Castledale, and Tuesday, Thursday, Saturday she lives in Huntington. But can she ever live in both of them at the same time? You're either one or the other, right? Even if you lived where two cities met, which doesn't happen in Emery County, but in other places they do, and there's an actual border. Well, what if your bed was right on the border, and half of you slept in one city and half of you slept in the other? You still cannot be totally within one city at the same time. So for a function, the rule is, oh, and in the domain we call these our x's, and the range we call our y's. So the rule is every x has or only one y value. Can there be y values that have multiple x's? Can there be cities with lots of people living in them? Yeah, that's legal. And we see that here. We have 3 kids that live in Castledale and 2 kids that live in Huntington. This Reagan line doesn't actually exist. But the minute you start to attach one person to 2 cities, it ceases to be a function. So the rule for a function is for every x, there's one y. Now, you might have a y with lots of x's. If everybody in this room lived in Orangeville, that would still be a function. You'd have a list of all the students, and then you'd have the city Orangeville, and you'd have all these lines from the students to Orangeville. Okay? Now, what about Cheyenne? So Cheyenne doesn't have an arrow. And we said that the range is cities only. So how do we attach Cheyenne to a non-city? We can't. Okay? Now, Cheyenne exists. I assume you live in a house. Okay, some sort of dwelling. It's not a cave or a tent. All right? But that house just happens to be outside of the cities. So Cheyenne gets removed from the list. Not because she doesn't exist. She gets removed because she does not live in a city, therefore she is not part of the function. Even though she's a student in the class, she doesn't belong in the function because there's no arrow to draw. Does that make sense? Okay. One way to represent functions is with a graph. So if I draw a graph, and I can represent a function by coordinates of x and y. So x comma y, and I could have a whole list of them, 1 comma 2. So 1 comma 2, 3 comma negative 4. So 3 comma negative 4. Okay, we could say that person 2 lives in city 3. So 2, 3. Does this represent a function? Does every person live in one city? Yes. Person 1 lives in city 2, person 3 lives in city negative 4, and person 2 lives in city 3. What if I had a 5 and nothing to match it to? I don't know that it's actually 0. If it's unknown, it could be, so if I come out here to 5, it could be any one of these points, right? Which one is correct? I have no idea. Therefore, I throw this number out. It's not part of the function. Okay? What would I need to do to this list to destroy the function? What, what would I have to do to break the function rule? Let's go back. So I need an x that is linked to two y's. If I put 4 comma 3, is that okay? Can person 2 live in city 3 and person 4 live in city 3? Yes. So I could graph 4, 3, and that's perfectly fine. How could I break the function? 1 comma anything other than this. So if I had 1 comma 5, that would break the rule. Well, notice what happens with that point, 1 comma 5. Why is that a problem? Why are the points 1 comma 5 and 1 comma 2 a problem? This is Reagan trying to live in Castledale and Huntington at the same time, which can't happen unless you're Robbie, apparently. Robbie can do it. Okay, well, I want you to notice those 2 points are vertical from each other. Okay? Whenever you have 2 points that are vertical, that means that the x's are the same, but the y's are different. If the x's are the same and the y's are different, you don't have a function. So we could look at a graph and we can figure out if that graph is a function just by looking at it. So if I had this graph, does that graph represent a function? Yes. How do you know? We're looking for vertical points. So if I remove this line along the graph, does the line ever hit 2 points? No. Yeah, it's not a very straight line, but still, it never hits twice. Okay? So this is a function. All right, let's graph another one. Is that graph a function? No, why not? So if I move this along, tell me when I run into trouble. Right there. That's really not a straight line, is it? So here, we could call that -1, comma 1. And this one could be -1, comma 4. So person -1 is living in two cities at the same time, which means it is not a function. We call this the vertical line test. And that's half of your assignment today. Looking at a graph and saying, yes, it's a function. Or no, it's not a function. All right. What if we had a graph that looked like this? Is that a function? So if I pull my vertical line over, I run into problems right there. It hits twice, so it's not a function. Okay? Well, then we can run into tricky graphs like this. What do those circles mean? Do you remember when you did number lines? And you did inequalities and you had this? What does this mean? Everything bigger than 3. Does 3 count? Now, how do I include 3? If I filled it in, then it would include 3. Okay? So, if I draw a vertical line, is this a function? So what about right here? Doesn't that hit twice? The first one is an open circle, the top one. And because it's an open circle, it means it doesn't exist. But if I go over just a little bit, now it does exist. Right? And technically it misses the bottom. So this is still a function. It misses the top one and it hits the bottom one. Okay? What about is that a function? So you say no, where is the problem? Right there. It hits both the top and the bottom, so it's not a function. Okay? So now we're going to look at domain and range. Pull out my graph. And this is a little bit tricky. So if you get confused, please ask lots of questions, and we'll spend as much time as we need to figure this out. So let's look at the domain and the range. We know that the domain is the x values. So I want to know what x values belong to this graph. So this point is 0, 2. This point here is 3, 3. And that point there is 5, 5. So I'm just looking at my x's. So 0 is part, 3 and 5 are both part of the graph. Okay? Are there any x's that do not appear on this graph? That's a really tough question. So let's look at our x-axis. And I'm going to draw a straight line that goes right through my x-axis. So this is x equals -4, -3, -2, -1, 0, 1, 2, 3, 4, and so on. Okay? If I put this line on any x value I want, Are there any of those lines that miss the graph? Does that line hit the graph? Yes, it hits it right here. If I move it over, I could even throw it a little. I think I can throw it. Does that hit the graph? Huh? What if I move outside over here? Is that going to hit the graph? Eventually it will, because this graph is going to continue going up. Now, is it possible for that graph to curve and go straight up and down? That never happens. Okay. Is it possible for the graph to curve and come back to the right? Yeah, it can happen, but if that happens, it will be shown on the graph. So the arrows mean it's going to continue going in that direction forever. Okay? So, if I went to the other side, is that line going to hit the graph? Eventually it will. So, every single x is part of the domain. Every single x has a vertical line that will hit the graph eventually. So what we say is x equals every real number. That's equivalent of saying everybody in the room lives in a city. Does that make sense? So in this case, we don't have a Cheyenne that lives out in the middle of nowhere. Sorry. All right. What about my y values? So my range is a list of y values. So I look at my y-axis. What sort of line am I going to use to test my y-axis? Horizontal line or a vertical line? Horizontal line. So I draw a horizontal line that's perfectly straight. Okay. Does this horizontal line touch the graph? No. So person -3 does not live in a city, at least not one that's in our list of cities. Okay? Does oops. Does this line hit the graph? Everybody see that? These are all yeses, and everything down here is a no. Okay? So we need to describe all of the yeses. How would you say the all y values that are part of this graph? What set are we looking at? Well, let's start at the bottom. Tell me when I start getting yeses. Right there. What number is that? 2. Okay, so 2 works. Does 3 work? 4? When does that stop? It never stops. It goes all the way to infinity, right? So we're going to teach you interval notation. In interval notation, you write the smallest number that is a yes. And you said the smallest yes was a 2. What was the biggest yes? Infinity. Now, we're going to use parentheses. Well, either parentheses or brackets. Okay? Parentheses are the same as an open circle, a not equal to. And brackets are the same as closed circles or equal to. So, is 2 part of the answer? Yes, 2 counts. So we put a bracket around it. Is infinity part of the answer? Well, can we ever actually reach it? No. Can we say infinity is right here on the graph? No. The crazy thing about infinity is the closer you get to it, the further it moves away from you. You can never actually reach it. So every time you see an infinity, it's always open. So a bracket is called a closed interval, and a parenthesis is called an open interval. Now, don't get this confused with x comma y. That's not what this means. This means y is every number from 2 to infinity. Okay, let's try a different one. Is that a function? No. So on your assignment, you would write not a function. Okay? So let's test our x's. Are there any x's that miss the graph? Do some of them miss? Okay. So what's the smallest one that hits? Well, and we'll say -3, and then we just won't include it. So it actually is -3, but we'll just throw that number away. I'll show you how to do that. So my domain, x is, the smallest one is -3. What's the biggest one? Right there, a 3. So -3, comma 3. Now, does -3 count? Is -3 part of the answer? If I move my line over here, that was interesting, to -3, does that hit? No, it misses because there's a hole, an open circle. So is that a parenthesis or a bracket? Parenthesis, so equals parenthesis. Okay, what about 3? If I move my line over here to 3, does that one count? Yes. So 3 gets a bracket. Does anybody not understand how we got that? So essentially, every x from here to here gets counted. Everything bigger than -3 and everything all the way up to 3. Right? Let's look at our ranges. So now we need a horizontal line. Are there any y values that miss? Yes. What is the smallest y value that we're going to include? Right there, -1. So the range are the y values equal to -1, comma. How high can I go before I start missing? Well, 4 misses. Does 3.5 miss? That one misses. Does this miss? Does that miss? So, and that number is 3. Do we include -1? It's an open circle. So -1 is a open bracket, an open parenthesis. Do we include 3? Well, it didn't say. It didn't have a closed circle. So is it open or closed? Unless it says, it's always open. Okay? So this one would be a bracket. Okay? All right. Well, let's use this. Oops. And this will be an arrow too. All right. Domain. Are there any x's that miss? Careful. So if I draw a vertical line, does that vertical line ever miss? It misses right there. Now there are 2 ways to write this. So don't write it down until you figure out which one you like. Okay? I could describe the left side first. What is the smallest number on the left side? -infinity. Well, we're talking about further to the left or to the right. The left side of this is -infinity. What's the right side? -1. Do we include infinity? Never. Do we include -1? No, because it's open. Okay? Now, on this second portion, what's the furthest number to the left? -1. Do we include it? No. What's the biggest number on the left? Infinity. Do we include infinity? Never include infinity. Okay, that's one way to do it. Describe the left side and describe the right side. But an easier way would be we include every single number except -1. So I can actually say, I could do it this way, listed as two intervals, or I could say all real numbers but x is never equal to -1. So you can describe the left side and the right side, or you can say everything but this one number, or this, if there were two holes, you could say these two numbers. Okay, let's look at the range. Y is equal to. Are there any, oh, I did it again. Again. Are there any y values that miss? These miss, right? So what about this one? Does it miss? It misses over here on the left, but does it miss on the right? No, it hits on the right, and as long as it hits once, we're okay. So, what is the lowest y value that this touches? -3. What's the biggest y value it touches? Infinity. Do we include -3? Yes, so it gets a bracket, because down here it doesn't tell us whether it's open or closed. If it doesn't tell us, it's always closed. Do we include infinity? No, never. Okay, what about this? Let's do this. Okay, so my domain, x equals. Is this a function? No. It does not pass the vertical line test. Right there, it fails. Are there any x's that miss? What about that? That misses up here, but it touches down there, so we're okay. Are there any that it misses? Where? So, over here, is that going to miss? That's eventually going to hit, because this graph is going to keep going in that direction, and they're going to intersect down here. So what is the domain of this function? What's the smallest number it hits? Well, it does hit -2. What about -3? So it hits from -infinity. What's the biggest? Infinity. Does it miss anywhere in between? No, so we just say all real numbers. All of them. Okay? For my range, the y values, now I draw a horizontal line. Are there any y values that it misses? Yes, a lot. So let's deal with this piece. What is the smallest number that this reaches? All the way down to -infinity. So -infinity, comma, how high does this go? To -1. Do we include -infinity? So that gets parenthesis. Do we include -1? Bracket. Okay. What about the rest of the graph? Do any of these hit? No. Any of these? No. So where does it hit? At 3, anywhere else? All the way up to infinity. Oh, my goodness. Sorry. All the way up to infinity it hits. Remember, we're not looking this way. We're looking up and down. So it hits 3. Does it hit 3.1? So 3.1 would be right here. No. Does it hit 2.9? No. So the only thing it hits is y equals 3. Okay? So everybody in the classroom, so this says everybody in the classroom lives in a city, but not all of the cities have somebody living in them. City number 2 does not have a person in it, nor does city number 1 or 0. But city number 3 has it, and all of the cities down here have somebody living in them. Okay, your assignment tonight is to finish this worksheet. Good luck. You have about 10 minutes to work on it in class. If you need